Hi everyone, welcome to this channel, the Merchant Construct-preneurs and Tutors. Today we'll be calculating the quantity of materials in 1 cubic meter of concrete with a mix ratio of 1:2:4 and the water cement ratio of 0.4. So, from our basic definition of the concrete is a material that is produced when you mix cement, sand, granite, and water in a particular proportion. You get me? These are the 4 basic materials that forms a concrete. You have the cement, you have the sand, you have granite, you have water. So as illustrated in the picture there. So now we are going to take things step by step. Now the quantities were given to us in volumes, so we need to get the volumes, and also we'll now convert it to weight, and then we'll now convert to the cubic meter. Okay, so let's break down the quantity of the ratio that was given to us. We have 1:2:4, where cement has 1 part, 2 represents sand, 4 represents granite. Then the water cement ratio given is 0.4. So we are now going to take things step by step. So step 1, we are going to calculate the volume of each of these materials. Now this thing was given to us in ratio, so we need to convert it to the volume before we now take it to the next step. So now let us, from our basic physics, we know that density of a material is equal to the mass of the material divided by the volume of that material. So if we use volume as the subject of the formula, we have mass of the material divided by the density of that same material. I hope you can all recall from our basic physics. Okay, now so we are now going to take the volume of each of these materials one after the other. We'll start with cement. Now we know cement has a density of 1,440 kg per meter cube. Then the mass of cement, of 1 bag of cement, is 50 kg. Now cement is usually bagged, for smaller quantities, usually bagged in 50 kilograms, while for bigger quantities you have them as tonnage, 1 ton. So from our formula that we got there, density is equal to mass over volume. So using volume as the subject of the formula, we have mass divided by density of cement. So dividing 50 by 1,440, we have 0.035 cubic meter as that for the volume of cement. Now since this thing is in a ratio, so it is going to be represented. Sand, we take it as the ratio of the first one, so 2 times the ratio of that particular value, that is cement, that represents 1. So the volume of sand is calculated from the mix ratio, and sand is represented as 2 in that ratio. So the sand now volume of sand will now be 2 multiplied by volume of cement, 2 multiplied by 0.035. That was what was calculated for the volume of cement. So we have it as 0.07 cubic meter. I hope we understand this part. This was expressed in a ratio. So if we want to get the value of each of this ratio, we are going to be relating it with the value of the first item that was listed, that has the value of 1, that represents 1. So now we are going to do the same for the volume of granite. I hope you are following. So the volume of granite, we have it as 4. It has a value of 4 in that mix ratio. So doing the same thing that we did for sand, we are going to have volume of granite, we have it as 4 multiplied by the volume of cement. So we are going to have it as 4 multiplied by the volume of cement. So the volume of cement from our calculation is 0.035. So when you multiply 4 by that value, you're going to have 0.14 cubic meter. Sorry, I beg your pardon. 0.14 cubic meter. So the next thing now, we are moving over to the next step. Now, after we've converted the ratio to the volume, that is step 1, we converted the ratio to volume. Now, step 2, now we are now going to convert this volume to weight, because weight actually gives an accurate and exact answer. It gives a correct value compared to volume. Volumetric calculation can be affected by the size of the container, how compressible the material is, how loose the material is. For cement, for granite, for sand can be compacted to contain more. In granite, depending on the container, if you are using a head pan, it might be flat and you will not get that exact volume that you needed. So now we are going to list out all our parameters that are known, and those parameters include the dry loose bulk density of sand, the dry loose bulk density of granite, the water cement ratio, and also the mass of 1 bag of cement. At least those factors are known already. So the dry loose bulk density of sand is 1,450 kg per meter cube. The dry loose bulk density of granite is 1,650 kg per meter cube. The water cement ratio that was given in the question is 0.4. The mass of 1 bag of cement as 50 kg. I hope we are following. Okay, so we are doing it gradually. So from our basic physics, for our density of formula for density, we have density as the mass of a material to the volume of that same material. So interchanging the subject of the formula, making mass the subject of the formula. So we have mass of sand to be density of sand to the volume of sand, and these two other parameters are known. So 1,450 multiplied by 0.07, we have 101.5 kg. I hope you get this. So for the granite, we are doing the same thing. 1,750 multiplied by 0.14, you have it as 231 kg. Okay, so we are moving over to the next item. We already know the mass of cement as 50 kg. We know the mass of sand from what we calculated there, 101.5 kg. The mass of granite as 231 kg. So the mass of water, because water is part of the concrete, it makes concrete. So from the water cement ratio, we are going to get the mass of water from the water cement ratio. So we have it at 0.4 from the question. So mass of water to mass of cement is equal to 0.4. That is what water cement ratio is. It's simply mass of water to mass of cement. So using mass of water as the subject of the formula, we have it as 0.4 multiplied by 50. So we have it as 20 kg. So expressing the values for weight in ratio, we have it as 50 kg for cement, 101.5 for sand, 231 for granite, and 20 kg for water. I hope we get. So we have gone through 2 steps now. First one is to convert the ratio to volume. Now we're converting the volume to weight. Now the next step now is to calculate the volume of concrete that the mixed ratio can produce. So we're now going to use the values for the weight. Okay, so we are going to use the values we got. That's for the weight. We are going to use it for our calculation. So now, since this thing is expressing ratio, now we are now going to add everything together. The mixed ratio that was expressed in weight, we are going to add it together. You get? So we have it as 50 kg, which is representative of cement, 101.5 kg is representing sand, plus 131 kg that is representing granite, plus 20 kg that is representing water. So adding everything together, we have 402.5 kg. Now we are still going back to our basic physics, where we know density of a material is equal to mass of the material divided by the volume of the material. So now we know that density of concrete is 2,400 kg per meter cube. So using our basic formula for density, so we have this value as volume of cement equals 402.5 divided by 2,400. So we have a value of 0.167. So what this thing is saying is that this mix ratio that we converted from the ratio to volume, from volume to weight, everything, adding everything together, the volume quantity of concrete is going to make is 0.167 cubic meter. Again, now we are now going to calculate in terms of the standard, generally acceptable standard, if I may use that word, that is 1 cubic meter. Because if you are buying from batching plants, they sell per cubic meter. If you even want to express anything, you tell them, oh, this volume of this slab is per cubic meter, like how many cubic meters are in this. So now we are now going to calculate the quantity of each of these constituents of concrete that will be present or that will make up 1 cubic meter of concrete. You know, the last calculation was to calculate what each of these quantities was given to us. I mean the volume of concrete that it will give to us. But now we want to know what quantity of materials, whether for cement, for sand, for granite, or for water, that will be present to give us 1 cubic meter of concrete. So we are starting with cement. The quantity of cement required in 1 cubic meter of concrete. We have if 50 kilogram of cement gives us 0.167. So how many kilogram of cement will give us 1 cubic meter of concrete? So if you cross multiply, you have it as 50 divided by 0.167. So you have it as 299.4 kilogram of cement. This 299.4 kilogram of cement gives us 1 cubic meter of concrete that is going to be present for you to have 1 cubic meter of concrete. So now we are expressing it in the generally recognized way of bagging cement, which is in 50 kgs in small bags. So we have it as 1 bag of cement is 50 kilograms. So how many bags of cement is now going to give us that 299.4 kilogram that is in 1 cubic meter of concrete? So cross multiply, we have 299.4 divided by 50. So we have it as 5.99 bags of cement. So approximately 6 bags of cement. So 6 bags of cement is needed to achieve 1 cubic meter of concrete for that mix ratio 1:4 and water cement ratio of 0.4. It varies depending on the mix ratio, but the variation is not that much. It should still hover around that same value. So we are going to the next quantity and the next item, which is the quantity of sand required in 1 cubic meter of concrete. Now we are going to do the same thing. Now if 101.5 kilogram of sand gives us 0.167 cubic meter of concrete as calculated in our step 3. So how many kilogram of sand will be present in 1 cubic meter of concrete? I hope we are understanding this. So I hope you're understanding this, right? Okay, so we are having a value of 101.5 divided by 0.167. And now doing the calculation, we have it as 607.78 kilogram of sand. So this is what is required in 1 cubic meter of concrete. So now we are now going to express it in the language that is standard, the industry standard, that is in tonnage. So converting the quantity of sand from kilogram to tonnage. Now we have to recall that 1 ton is equals to 1,000 kilogram. So then how many tons will give you 607.78 kilogram? So calculating this, we have it as 607.78 divided by 1,000. So that gives us 0.608 ton of sand. So for sand now, we have this value that is present in 1 cubic meter of concrete. We are moving now to the next item, which is granite and concrete. You know, cement, sand, granite, and water mix of concrete. So we've gotten for that of cement, we've gotten for that of sand. Now we are going to get for that of concrete, for that of granite. I beg your pardon. Okay, so quantity of granite required in 1 cubic meter of concrete. If 231 kilograms of granite will give us 0.167 cubic meter of concrete. So how many kilogram of granite is in 1 cubic meter? So changing this over to the formula, we have 231 divided by 0.617. So we have it as 1,383.23 kilogram of granite that is required in 1 cubic meter of concrete. So converting it to the industry standards, that is in tonnage. So to convert the quantity of granite to ton from kilogram to tonnage. So you are going to recall that 1 ton equals 1,000 kilogram. So how many tons of material give us 1 cubic meter? So we are doing the same thing, 1,383.23 divided by 1,000. So we are having it as 1.383 kilogram of granite. So you see that we are gradually getting our quantities right, getting these things ready. So we've gotten for that of cement, we've gotten for that of sand, we've now gotten for this of granite. So water is not going to be left out. We are also going to calculate for water. So now the quantity of water required in 1 cubic meter of concrete, we're also going to calculate it. So now, for the calculation we made in step 3, where we have 0.167 cubic meter of concrete, 20 liters, 20 kilogram of water is required. Now we are going for 1 cubic meter, so we need to calculate for that too. So we have it as 20 kilogram divided by 0.617. So we are having a value of 119.76 kilogram, which is approximately 120 kilogram or 120 liters. From a basic conversion, for water, 1,000 liters equals to 1 kg. 1 kg equals to 1 liter. Vice versa, 1 kg equals to 1 liter, 1 liter equals to 1 kg. So, having gotten this now, we can now say that we've gotten all the quantities that are required in 1 cubic meter of concrete, given the mix ratio of 1:4 and the water cement ratio of 0.4. So the cement is 300 kilograms or 6 bags. For sand, we have it as 608 kilogram or 0.608 ton. For granite, we are having it as 1,383 kilogram or 1.38 tons. For water, we are having it as 120 kilogram or 120 liters. So with all these values now, we can say to ourselves now that we can calculate. I'm very sure that we can calculate for other mix ratios using this as a guide. You get me? Whether the mix ratio is 1:1, 1:2, 1:3, 1:6, 1:1.5,